Hi, so we are live and it's already 14th day with our near nums. Rotate the array in the right by k steps, where k is non-negative. So for example, we have 1, 2, 3, 4, 5, 6, 7, and we need to rotate to 7, to 3. So it means it's actually start from 5, right? So we rotate like we swap through 3 elements and yeah. And go. So first rotation we go 7, then 6, and then 5. Okay, so by 2, yeah. So I think that I pretty understand the question. So first we receive an array in key, and we need to return the same array and rotate this array. So let's ask about constraints. So I expect that the length of our array is more than k, not more than k, but it's more than 0 or equal to 1, and is about 10 in fifth power, right? It doesn't matter what what k we have and what nums we have, so so we can also say that k have the same length. So constraints pretty straightforward. So the main follow-ups that we can ask, can we use additional memory? And here, could you in place move these things and try to come up with as many solutions as you can? There are at least 3 different ways to solve this problem. So let's think about approaches here. So the first approach is actually to find the k value and create an array and then copy from this value to the end and from start to this value. Yep, so it's pretty straightforward, understandable. So it's just a new array and from mid to finish and from start to mid. In this case, we have time complexity of n, space complexity of n, because we need to create new array. What else we can do here? We can do like one by one, right? So we can we can shift all this value by 1. So for example, we store the last element, and we shift all values to the end and put first at the beginning, then again until we have k. So it's like shift algorithm, and here we need like this shifting logic. The shifting it's n and then n. So here it's actually m over k, but inverse complexity can be m squared, and space, I think we don't need space here. So it's quadratic, but it's too complex for now. So let's try to solve this question with constant space and linear time. So with constant space and linear time, we know that we know our starting position, right? K. And if k is greater than array length, we should do like mod of our case. So for example, if I need, so if I have something like this, so imagine I have 1, 2, 3, 4, and I need to, and k equal to 5. So it means when I swap 4 times, right, it would be the same result. So if it would be the same, because like after one swap, let's do it. So after one swap, it would look like this. After 2 swap, it would look like this. After 3 swap, it would look like this. And on the first swap, it will look the same way. And on the 5th swap, we have this, we have again and again. So actually, we have, as you see, only 4 possible options, right? And so we can actually, we should take the mod operation of k and to understand how many swaps do we need. And in this case, we know k. So let's say that k is 3, right? So here is 1, or here's 1, here's 2, 3, 4, and we need 3, right? So we need 3. So what we can do? If we need 3, we know the starting position, and we know that till the end, all this element will be swapped here, right? And this one, and all this element here should be positioned on, I think, so it 2, 3, 4. So we put here, and we know that, yeah, this one should be pointed here. And this 3 should be pointed here. So how we can do this? Yeah, I think this first approach, it's like the most obvious and optimal in our case, but without space, yeah, without space, we need something here. So we need some 2 pointers. So 1 pointer is k, so it's 2. And so we need to like start swap 2. Yeah, we need somehow to move all this at the beginning and all others at the end. So, for example, I first put 2 at the beginning, right? Then I put 3 here, then I put 4 here. So for all my values, I actually put them and swap with previous. And yeah, so seems that it should look like this. So I have this pointer, and I'm actually swapping until I will reach this pointer. Then I go to this one, and I'm swapping until I will reach this one. Then 4 until I will reach this one. So it will be not, it can be n. It's like not to n. In worst scenario, I believe it can be n squared, right? Yes, so it looks like sorting mechanism. Sorting mechanism here. Yeah, but in this case, we not use any space here, right? So let's try to implement this. So we have ni. It's the position of nums length of mod k, right? And this is our starting position. And then we have a j. So the j, it's like position of how we need to like position of where this first a should be placed. And we do the following. So while Yeah, I think we need not while, but maybe for, and here it would be yes, this I. So from here to I. Okay, so we start with I, and then while I is less than nums length, I++, so we take the next value, it would be swapped back, and here we do like swap operation of I, and yes, and j, and here we increment our j, and here we just finish. And how we do this swap, so it would be void swap, and here we also need nums. So we have this nums, then we have int I and int j, and we do it within while I is greater than j. We take value that we want to swap. It would be temporal value, and it's nums I minus 1, right? And we put into nums I minus 1 nums I, and then we put into nums I the TMP, and after this we need to decrement I, right? And yeah, and do the following things. So let's actually run this and check how it works. Okay, so we have 2, 3, 4. Here it says 3, so it's like we have 1, 2, 3, 4, 5, 6, 7. We have 3, so it will be 1, 2, 3. Yeah, so we should start with 5 and start swapping them. So let's debug this code. Yeah. So here I think that this one is incorrect. We should do like this. So here it would be 3, but then we should identify where we start, because here we like start with 3, but it should be nums length minus, and this one should be 3, right? And it should be vice versa. It should be k mod nums length. Yep. So in total is 7, and 7 minus 3, it should be 4, right? So 0, 1, 2, 3, 4. So it should be 5, right? Okay. Yes, now it's correct, and let's run. And we are time limited. Yeah, so time limited because, as I said, it's actually time, and for big numbers it can take a lot of time. So let's do the following. Let's implement this logic with new array and just do very simple work here, and then just verify where we did a mistake. So again, we need this I, right? So this I is quite important for us for this task. And then we need to create a result array. So let's do it. So we create result array, and then we need just to go through result array and just update our nums. So it will be result array with nums length, and then what we do, we go through I equal j equals 0 and j less than I, j plus plus, and we put into our result j all elements in nums j, right? Yeah. Oh no. So at the beginning, we should put all elements starting from I. Yeah. Until nums length and starting from I. And then here we have like k, and k we will increase, and then we are going through j. It would be yeah, so now it should be from 0 to j equal to I, j plus plus, and here we put result k plus plus, we put nums j, and after this we just go, we are result, and we just update all values nums with result. We already have k, so let's have here m. So here it should be, let's say j, and submit. So yeah, now it works, but it works with very, yeah, with, as we said. So let's check. Okay, so what we can do here, we can do reverse start and end from 0 to end. So first we do reverse of whole array. Yeah, and then we reverse each part. We do reverse each part. So here it's much more, yeah, much more intelligent. And I think during interview you should get this idea. And this idea, yeah, it's very intelligent and logical, because this shifting thing, the third thing that we implemented, yeah, it's quite complex because we put each value. Yeah, so I think that here we see that I implemented this way and also implement this way. The same 22, yeah. And here I implemented the way that we have today. Yeah, it's here some very strange thing. All right, so I think, done with this task. And how much time we left? So we 20 minutes done. So I think we don't have time to continue with this one. So let's do tomorrow more tasks. Thank you, and see you tomorrow.